Hey there, and welcome. Have you ever stopped to think about how you're even seeing this right now? Well, today we're diving deep into the physics of light, the invisible energy that literally builds the world around us. And trust me, by the end of this, you might just question everything you think you know about seeing. So let's just jump right in with a bit of a brain teaser. We talk about seeing the lights all the time, right? But have you ever seriously asked yourself, can you actually see light itself? Get ready for this, because the answer is no. You can't. You don't actually see light at all. What you're seeing are the things that light hits. And that little paradox, it's the key to understanding, well, everything. So if we can't see it, what exactly is this invisible force that paints our entire world? So here's the big secret. Light is the invisible energy that makes everything else visible. It's kind of the ultimate artist working behind the scenes. And to really get how it works its magic, we first need to know the basic rules of the game. Okay, so light basically plays by three simple rules. First, it's a form of energy. Second, as we just established, it's totally invisible to us. And third, it travels in dead straight lines. Think of a laser pointer. That beam doesn't bend or curve, does it? That's a fundamental property. Now, with these rules in mind, let's explore what happens when this straight-shooting, invisible energy actually hits something. All right, so the first path light can take is reflection. This is exactly what it sounds like. It's when light bounces off a surface. This is what's happening when you see yourself in a mirror, or even when you see the moon shining in the night sky. A really great way to picture this is to think of light like a tiny tennis ball. It flies through the air, hits a wall, and boing, it bounces right off. That's reflection in a nutshell. But it's not chaotic. Oh no, it follows a very, very precise law. And here's the really cool part. It follows a super precise rule. The angle that the light comes in at, that's called the angle of incidence, is always exactly the same as the angle it bounces off at, which we call the angle of reflection. Always. This one simple rule is the secret behind how every single mirror works, and it lets us do some pretty clever stuff. For example, here's a real-world puzzle for you. You're driving. You look in your rearview mirror and you see an ambulance behind you. And the word ambulance on the front is spelled completely backward. Why would they do that? It's not a mistake, I promise. It's actually a genius use of physics. And to get it, we need to talk about another cool effect of reflection. The reason this happens is because of something called lateral inversion. It's that familiar thing a mirror does, where it flips everything from left to right. You know, you raise your right hand and your reflection raises its left. The image is perfectly reversed. The source material has a funny line about this. If your reflection doesn't do this, you might have a ghost on your hands. And here is where it all clicks. When you see that backward ambulance text in your rearview mirror, the mirror performs its lateral inversion trick and flips it back the right way, so you can instantly read the word and know to pull over. It's a simple, life-saving piece of applied physics. How cool is that? Of course, mirrors aren't always flat. When you curve them, you can bend light in some really useful ways. First, you've got concave mirrors. They curve inward, like a cave, see? Easy to remember. They gather light to a single point, which magnifies things. That's why your dentist uses one to get a super close-up look at your teeth. Then you have convex mirrors, which bulge outward. They do the opposite. They spread light out, giving you a much wider field of view. Think about the side mirror on your car, the one that says objects in mirror are closer than they appear. That's a convex mirror at work. So, bouncing is one option, but what happens if light doesn't bounce off something? What if it goes through it, like through glass or water? Well, that's when things get even weirder. The light actually bends. This is the second path, and it's called refraction. So, refraction is just the official term for the bending of light when it moves from one substance or medium to another. And the reason it bends is fascinating. It's because the light literally changes speed as it crosses the boundary. And just like reflection, this bending isn't random. It follows two clear rules. When light goes from a thinner medium like air into a denser one like glass, it slows down and it bends towards an imaginary center line. But when it goes from that denser medium back out into the thinner one, it speeds back up and bends away from that center line. Now, if you're worried you won't remember which way it bends, the source material actually has this awesome little mnemonic. Just think of the initials RD. When light goes from a rarer to a denser medium, it bends towards the normal line. It's a super handy little trick to keep it all straight. Okay, so we have light bouncing and light bending. reflection, and refraction. These aren't just abstract ideas in a physics textbook. They are, quite literally, the magic that powers so much of the technology we use every single day to see and make sense of our world. Think about it. Every time your dentist gets a magnified view of your tooth, that's reflection. Every time you check that side view mirror on your car for a wide angle, that's reflection. But every time you put on eyeglasses to see clearly, or snap a photo with your phone's camera, or look through a telescope, you're using the power of refraction. In fact, your own eyes are absolute masters of both, constantly bending and focusing invisible light to create the rich, colorful world you're seeing right now. So, the next time you see a straw that looks bent in a glass of water, you'll know exactly why. You'll understand the physics behind the illusion. So my question for you is this. Now that you know about these two paths of light, what are you going to notice in your daily life that you've never really seen before? I'm going to leave you with this beautiful thought from our source that kind of turns all this physics into a pretty great life lesson. Reflect positivity, refract negativity, and always focus on your goal. Thanks so much for joining me.